Protecting fish stocks with smarter risk management. Fisheries are a vital source of food, livelihoods, and cultural identity for many communities across the globe. Unfortunately, fish stocks are collapsing, despite management plans designed to ensure sustainability based on rigorous stock assessments. These collapses devastate ecosystems and the communities that rely on them, raising an urgent need to balance competing demands for fish with preserving stocks for the future. Dr. Benjamin Blanz at the University of Hamburg and his collaborators are taking a new approach to this challenge. They developed a method to communicate the short and long-term risks of fish stock collapse under various harvest scenarios. Their work provides fishery managers with clearer insights into how their decisions can impact the future of fisheries. The team's simple yet powerful method is based on predictions of the likelihood of fish stock collapse over time, accounting for natural causes of fish death, fishing activities, and environmental changes. They demonstrated their method using a simple model, but it can be applied to state-of-the-art stock assessment models. The innovation lies in the use of risk matrices, a tool commonly used in industrial risk assessment to communicate harvest risks. Green cells within the matrix indicate tolerable risk, yellow and orange signal moderate risks, and red highlights a catastrophic risk of stock collapse within a short time frame. As these commonly do not show the uncertainty distribution, the team extended the concept to communicate not only the riskiness of a choice, but also the distribution of the risk over time. Each fishing level is represented by a line through the risk matrix, indicating the increasing risk of stock collapse over time. These matrices make complex data accessible, allowing managers to see how different harvest levels could affect the sustainability of a fishery over time. The team's research project, Sea Use Tip, was originally focused on identifying tipping elements in the German North Sea, such as stock collapse. However, understanding the full scope of these risks requires long-term data from fisheries that have actually collapsed. To this end, the researchers collaborated with Canadian colleagues to study a cod fishery in the southern Gulf of St. Lawrence, which provided a historical record of stock assessments. In 1986, the cod stock was relatively large in this fishery, offering a buffer against collapse. However, increasing natural death rates, partly due to a growing seal population, significantly shortened the time the fishery could be sustained under high harvest levels. By 2017, the situation had worsened to the point where even halting fishing entirely could not guarantee the stock's recovery within 25 years. Blanz's method shows how the probability of collapse within chosen time horizons increased over this time period, offering a full picture of risk over time. Rather than simply determining how much fish can be caught in the next season, this research introduces a new perspective: how long a fishery can continue under a certain harvest level. Blanz and his colleagues hope that their approach will help managers, policymakers, and fishers to better understand the long-term viability of fisheries. By shifting the focus from short-term yield to sustainability, it supports efforts to protect marine ecosystems and food security for future generations.